Today, we're digging into the hidden code that runs our modern world and how, sometimes, it's the only thing standing between success and absolute disaster.
It can all come down to this. Just a simple phrase, right? But behind it, there's a terrifying amount of complexity.
And this is the human cost when that error happens in the wrong place at the wrong time. This isn't just a statistic. It's the direct result of software going wrong.
All right, let's really dive into this. Because that number, that's just the tip of the iceberg. It's the start of a much bigger, much more critical story about something we all take for granted every single day: software quality.
I mean, think about it. You're interacting with unbelievably complex software all the time. The phone in your pocket, the car you drive, the systems that handle your money, your health. We just trust it to work.
So what happens when that trust is broken? And maybe more importantly, what's supposed to stop these disasters from happening in the first place? Well, the answer lies in a set of rules.
And that's where we get into the world of standards. These are the formal rules of the game designed specifically to prevent software disasters before they can even start.
So what are they exactly? Well, a software quality standard is a formal set of criteria. Think of it like a blueprint or an instruction manual that tells developers how to build, test, and maintain software so that it's reliable, efficient, and, most importantly, safe.
It really boils down to two key perspectives. On one hand, you have ISO/IEC 25010. That's all about the what. It evaluates the quality of the final product, the thing you and I actually use. Then you've got IEEE 730, which focuses on the how. It audits the quality of the process used to build that software.
So let's break down that ISO standard. It's looking at the product across 8 key areas. Does it actually do what it's supposed to? Is it fast? Does it play nice with other systems? Is it easy to use? And, the really big ones. Is it reliable and is it secure? It's basically the checklist for what makes software good. And then there's the IEEE standard. This is all about making sure the development team has a rock-solid plan. It defines how to map out quality control, how to verify that the software meets all its requirements, and how to manage risks along the way. It's really the discipline behind the whole creation process. So, here's the million-dollar question. If these powerful rules exist, these blueprints for perfection, why do disasters still happen? The answer, as always, is in the real world. We're going to look at 4 cases that show exactly what happens when these rules are ignored or just plain not followed correctly. Our first case, the Therac 25. This was a radiation therapy machine from the 80s, and it was designed to save lives.
But it failed, catastrophically. A software error caused the machine to deliver massive overdoses of radiation, leading to severe injuries and deaths. The root cause? A complete and total lack of rigorous software testing and validation. They just skipped the most basic rules.
All right, let's jump forward to 2016 and something a lot more familiar: the Nest Smart Thermostat. This one shows that these failures don't just happen with, complex medical equipment.
So in this case, a faulty software update completely drained the device's batteries. The impact? Thousands of people were left without heat in the middle of winter. And the cause, once again, points right back to a core principle: not enough testing, specifically on the firmware and its compatibility.
Now let's head over to the world of finance. Back in 2015, a glitch in the HSBC Bank's payment system over in the UK caused absolute chaos.
Their main system went down right before a major holiday weekend, leaving 275,000 payments completely unprocessed. We're talking salaries, mortgage payments, everything just frozen. And guess what? Once again, the culprit was a system update that just wasn't tested properly.
And finally, the case that brings us right back to that number from the beginning, the Boeing 737 MAX.
2 fatal crashes, one in 2018 and another in 2019, cost 346 people their lives and racked up over $20 billion in losses. The culprit was a piece of software called MCAS that was activating when it shouldn't have. And really, this case is the perfect storm of disaster. It wasn't just one single bug. It was a deep, systemic failure in the software's design, its testing, and critically, its documentation.
So when you connect the dots, what's the big takeaway here? What's the pattern that links a radiation machine from the 80s to one of the most advanced airplanes in the world?
This chart really says it all. This isn't about bad luck. In every single one of these cases, a fundamental quality principle was ignored. With Thera 25, it was a total lack of rigorous testing.
For Nest and HSBC, it was inadequate testing on system updates. And for Boeing, it was huge deficiencies in the design and documentation. They're all just different flavors of the same basic mistake, not following the rules.
And this brings us to the most important conclusion of this entire explainer.
So here's the crucial point. Having a rulebook is completely useless if no one reads it or if they just decide to skip chapters. The mere existence of standards like ISO and IEEE doesn't guarantee quality. Quality only comes from applying them rigorously, without compromise.
Because when they are applied correctly, these standards do exactly what they're supposed to do. They protect lives, like we saw with Theric 25 and Boeing. They protect reputations and resources, like with Nest and HSBC. Quality isn't a luxury feature. It's an absolute necessity. So, I'll leave you with this question. The next time you get in a car, use a banking app, or just trust a smart device in your home, I want you to think about that hidden code that makes it all work. And ask yourself, how carefully did they follow the rules when they built this? Because the answer to that question matters a whole lot more than you might think.